Okay, today we're going to talk about conditional statements. These are statements made in two parts, has a hypothesis and a conclusion, commonly written in an if-then form. The if contains the hypothesis, then contains the conclusion. If we look at the example below, you see that if it is raining, this is the hypothesis, then there are clouds in the sky. This is the conclusion. That's a conditional statement in if-then form. So let's practice and see if we're able to identify the hypothesis and the conclusion. The hypothesis here in the first one, if today is Wednesday, and the conclusion, then tomorrow is Thursday. And again, the hypothesis in the second, if two angles are vertical angles, then they are congruent. Hypothesis and conclusions. So, on the one below, identify the hypothesis and the conclusion and write it in the if-then form. So I have the statement, all vertebrates have a backbone. So I could write this as an if-then. If it is a vertebrate, then it has a backbone. And in the example below, all triangles have three sides. So I could write this as a conditional statement. If it is a triangle, then it has three sides. And that's all it takes to write a conditional statement. If and then, the hypothesis and the conclusion. Now there's three statements related to the conditional statement. The first is the converse, which is formed by simply switching the hypothesis and the conclusion. So if I take this statement here, if two angles have the same measure, then the angles are congruent. To create the converse, I simply flip. This is the hypothesis, conclusion. So I flip them or reverse them. So if two angles are congruent, then they have the same measure. And I have the converse. It's simply reversing the hypothesis and the conclusion. Now you try. And when we make the converse of this, we have if the sum of two angles is 90 degrees, then the two angles, or they, are complementary. So we have the hypothesis and the conclusion, and we've simply reversed them to create the converse. The next related statement is the inverse. This simply negates, using the term not, the conditional statement. So if I take the same, if two angles have the same measure, then the two angles are congruent. To create the inverse of this, I simply say, if two angles do not have the same measure, then they are not congruent. So by negating, using the term not, we've created the inverse. The last one, the contrapositive, negates the converse. So we flipped the hypothesis and the conclusion to create the converse, and then we simply negate it, use the term not, in order to create the contrapositive. So in our original conditional, again, we have if two angles have the same measure, this is the hypothesis and the conclusion. I flip them to create the converse, and then I negate it to create the contrapositive. So if two angles are not congruent, then the two angles do not have the same measure. And that's the contrapositive. We'll get more practice with those tomorrow. Biconditional statements is a special type and contains the phrase if and only if. This is the key here. And it must have both the conditional and the converse true. Take a look at the example below. If two angles are supplementary, then the sum of their measure is 180. Sorry, this should say is. That is a true statement. We know that supplementary means 180. So the converse simply flips the hypothesis and the conclusion. This is going to come over here, and this comes over here. So if the sum of the measures of two angles is 180, then they are supplementary. This is also true. So this creates the biconditional statement. And we say, if two angles are supplementary, I'm going to abbreviate here, or rather, two angles are supplementary if and only if the sum of their measures is 180. And that's a biconditional. You're now making the statement if and only if. Remember, this is the big part. If and only if. And both the conditional and the converse must be true. Try the example below. If two angles are complementary angles, then the sum of their measure is 90. We know this is true. Complementary means they total 90 degrees. The converse then says, if the sum of the measures is 90, then two angles are complementary. This again is also true. So the biconditional statement would then read, two angles are complementary if and only if the sum of their measures is 90. And that's a biconditional statement. Again, if and only if. Both the conditional and the converse must be true.